Good morning. My name is Professor Moira O'Brien, and today is my first day as Dean of the Faculty of Science. And this is my first official event, and it is wonderful to be here. I'd like to start by acknowledging that I am addressing you today from the lands of the Wurundjeri people, and to pay my respects to their elders, past, present, and emerging. With our audience spread across the country, I'd also like to extend my respects to all traditional owners and to any First Nations people joining me today. Welcome to the Melbourne Energy Institute's third annual symposium, showcasing the University of Melbourne's multidisciplinary energy research across 4 themes: energy systems, power generation and transport, hydrogen and clean fuels, and environment and resources. These themes, and the MEI as an institute, represent core components of a larger Faculty of Science and indeed whole university objective: achieving and maintaining a healthy environment and combating climate change. Clean energy systems are crucial to this goal. MEI's model of engagement with industry, community and government is also a fantastic example of the active collaboration and cross-disciplinary research that is needed to solve our most pressing climate problems. Today, you'll hear from some of our remarkable graduate students and research staff who are conducting cutting-edge research across diverse areas within the university. I am honoured to introduce the 2020 plenary speaker, Dr. Alan Finkel, AO, Chief Scientist of Australia and Deputy Chair of Innovation and Science Australia. Dr. Finkel commenced as Australia's 8th Chief Scientist in early 2016. Prior to his appointment, he served as President of the Australian Academy of Technology and Engineering and for 8 years as Chancellor of Monash University. As Chief Scientist, Dr. Finkel chairs the Expert Advisory Panel for the CSIRO report on climate and disaster resilience and the Technology Investment Roadmap Ministerial Reference Group. He led the development of the 2019 National Hydrogen Strategy, the 2018 STEM Industry Partnership Forum report, the 2017 review into the national electricity market, which was known as the Finkel Review, and the 2016 National Research Infrastructure Roadmap. Dr. Finkel has an extensive scientific background as an entrepreneur, an engineer, a neuroscientist, and an educator. He was awarded his PhD in electrical engineering from Monash University and worked as a postdoctoral research fellow in neuroscience at the Australian National University. We are very pleased to have him with us today. Without any further delay, please welcome Dr. Alan Finkel.
Well, thank you, Moira, for that kind introduction. I've titled this talk Pivoting to the Future because, as you will see, the country, Australia, is moving in a direction that might have been hard to anticipate just a couple of years ago. I'm going to talk to you about the journey that Australia is on. It's a journey that's been going for quite some time. It started 20 years ago at small scale with the renewable energy target, which did build up and was very successful at bringing more solar and more wind into the market. It continued with an efficiency plan, which has perhaps not been as significant. The Climate Solutions Fund, which is the new name for the Emissions Reduction Fund. These are all moving towards low emissions technologies or extracting carbon dioxide from the atmosphere. One of the projects that I was involved in is called officially the Independent Review of the National Electricity Market, but it was more commonly known as the Finkel Review. And what was particularly significant about it is that it recommended, and we've seen the adoption of, new rules in the market to ensure that as solar and wind generators are connected at large scale, they don't destabilise the system. An integrated system plan is the design of interconnectors beyond just looking at the point-to-point economic benefit, but looking at the national benefit to bring electrons from where they're being generated to where they're needed across the length of the east coast of Australia, the national electricity market. Following on the electricity review, 2 years later, and adopted last year in full, we had the National Hydrogen Strategy, which is part of our long-term investment into a low-emissions future, and I'll talk about that in some detail later on. It's been very well recognised around the world. And just in September of this year, we had the announcement by the government of the Low Emissions Technology Statement, another very significant milestone marker on the highway into that sunny future. Australia is on a journey to a low emissions future. Of critical importance, the Low Emissions Technology Statement that I want to talk to you about now is owned by the government. I chaired the panel that advised the government, but it was not an independent review where we threw 20 or 30 recommendations over the fence to a government through the minister. In fact, we were advising the minister and his staff in the development of this strategy. And it was quite effective. They took the advice from the ministerial reference panel that I chaired. There were 6 other members. I won't go through their names. They're all there, visible to you. Expertise in industrial logistics, public policy, investment, development, gas, electricity, you name it. The process was sufficiently rewarding that the government has decided to make it permanent, and we're now adding in ex officio the chair of the 3 government agencies that are involved in low emissions technologies and investments. So the chair of the CER, the Clean Energy Regulator, the chair of ARENA, the Australian Renewable Energy Agency, and the chair of the Big Green Bank, the Clean Energy Finance Corporation, the CEFC. And this new council, as it's now called, will continue indefinitely to advise the government on annual updates to the low emissions statement. Now, when we began the development of the low emissions statement, we had a number of clear principles, and I've got 3 here to highlight. The first is all of us deeply, including the government, deeply accept the science of climate change. It's proven, it's not in dispute. This report wasn't there to prove or disprove climate change. It takes that as a starting place and accepts the second principle that Australia and the world must reduce emissions effectively as quickly as possible. But we have to do that whilst ensuring our prosperity. We're not looking for a trade-off. And this is captured in the vision. If you look at the vision statement, it's for a prosperous Australia, so that's the economy, if you like, recognised as a global low emissions technology leader. We want our cake and we want to eat it too. We want a strong economy and we want to be driving emissions lower and lower. We categorised technologies into 4 big groups, 4 categories. The first and most important was what we call the priority low emissions technologies. These are sufficiently important that the government sees the need to invest and to invest now and to encourage private industry to invest. The second is the emerging and enabling technologies. Enabling technologies are things such as behind-the-meter operation of electricity inside buildings and artificial intelligence in the electricity supply. Watching brief are the very long-term but still high potential technologies, but they're just not ready for government investment at the moment. And we've got a category called mature, and to some people this will be surprising. Of course, coal and oil are there and not getting attention, but also solar and wind and hydro, catchment hydro or large-scale hydro in that category, because the reality is investors are investing big time in solar and wind electricity generation today without specific government financial support. The market has to be well designed and nurturing of those investments, but they're not needing at this stage financial investment from the government. So how do we select the priority technologies? When we started the process, we did an exercise where CSIRO, ARENA and the Department of Energy of the Commonwealth Government just did a big collation of all the technologies that were out there that were considered to be low emissions technologies, and they had 140. It was way too many to be considering. So through the panel that I was chairing, we agreed on 4 filters to help us narrow down those 140 to the handful that we ended up with. The first is they had to have large abatement potential. There's really no point the Australian government investing in technologies that will make a pitiful difference to the reduction of greenhouse gas emissions. They had to be large abatement potential. They also had to be of significant economic impact. We're trying to build the economy and reduce emissions. Ideally, they will build on Australia's comparative advantages. For example, the fact that we have lots of sunshine, lots of wind, and lots of land to go with them means that anything that uses renewable electricity as an input is building on a comparative advantage. And they, fourthly, had to be a technology where government investment would actually make a difference. If it's either going to be immune to encouragement or get there anyway, it didn't seem that we should be selecting those. So the categories that we selected, there are 5 of them. The first one is clean hydrogen, which is something that has already been covered but has now been collected up into this overall low emissions technology roadmap. The second is the storage technologies, particularly batteries and pumped hydro, but also solar thermal. The storage technologies that enable solar and wind electricity generation at massive scale to come into the market and be firmed up so that they can deliver, of course, even when the sun's not shining and the wind's not blowing. The third is low emissions metals, specifically low emissions steel and low emissions aluminium. These have huge future export potential for Australia. The fourth and the fifth are to do with removing carbon dioxide from the atmosphere, because even when we do everything we can, we're not going to achieve net zero by zeroing out all emissions. There will always be emissions from hard to abate industries and activities. So the fourth one is geosequestration and the fifth one is biosequestration, specifically looking at storing organic carbon, so carbon dioxide taken out of the air and stored as organic material in the soil. So what does this technology statement signal to investors? Everybody's looking for investment certainty. Now, I've got a picture there of a big building. Some of you will recognise that as the Bank of England. The only way that investors can have certainty on a financial return is by putting their money in the bank. And of course, that's not what business investors are looking for. So no, it doesn't give certainty, but it does give policy direction. And that's the most, I think, that investors can be looking for. And that policy direction is flagged by a number of things. On release of the low emissions technology statement in September, it was clear that the government committed $2 billion for the subsequent budget a month later for these low emissions technologies. And the statement also flagged that the government would make a further commitment of $18 billion this decade. It doesn't say there won't be more, but there will be $18 billion this decade. And the plan is anticipating, based on historical precedent in Australia and internationally, that will be supplemented by between 3 and 5 times more dollars from industrial developers and investors. So we are looking at around about $100 billion or thereabouts going into low emissions technologies this decade in Australia. The second factor that provided policy direction is we've made it very clear that this was not a once-off. There'll be an annual update to the low emissions technology statement to Parliament, and it will be refining the policy as we learn more about the development. We need to adapt. We can't just say this is how it will be for all time. So we're going to be adaptive. There'll be policy refinement, but the statement has made it very, very clear that we're not anticipating or intending right-angle turns or U-turns. We're talking about refining an ongoing policy rather than jumping from one policy to another. And finally, the statement is, and the supporting budget is putting investment into translational R&D, demonstration projects and deployment projects to support the intentions declared in the statement itself. Now, since then, there's been a few myths around. Actually, I'd say that the statement has been incredibly well received. But there are some myths out there. I thought I'd quickly go through those. One is the criticism the government is picking winners. People like to criticise the government, and this is one of the criticisms you hear from time to time. The reality is that the low emissions technology statement is a portfolio. As I said, it's hydrogen, it's storage, it's low emissions metals and sequestration. It's a portfolio, which is what any sensible investor would do to spread the risk. If the government doesn't make some commitment, it's abrogating its responsibility. If it only committed to one technology going forward, you could criticise it for picking winners. I think it's a very sensible approach. All of those technologies are focused on atmospheric emissions reduction as the outcome. They're not, yes, there are technologies there, but they're not chosen because we love the technologies. We're chosen because they've got large abatement potential and they make economic sense. So we'll throw that one out. The second one is that it's all about gas or about natural gas. Well, actually it's not. It's about using batteries and thermal storage and pumped hydro so that we can bring more solar and more wind electricity into the systems, into the grids around the country. It's about zero emissions steel and zero emissions aluminium. And it's about clean hydrogen. And if I'm being generous, I'll say, well, hydrogen's a gas. Maybe that's what they're talking about, but they're not. It's a myth. This is not about gas. This is about, as I said, storage and other low emissions technologies. There is a criticism that there is no overarching target, but there are stretch goals. So every single one of those technologies has associated with it a price target that would allow that new low emissions technology to compete against the high emissions incumbents and therefore displace them. So there are stretch goals, and the tactics and strategies in the document are based on principles and pathways directed towards low emissions. And finally, criticism that's all about CCS and coal-fired electricity. It's not, but they are part of the portfolio and they're a necessary part of the portfolio. It's not us making that up. The United Nations, IPCC, the International Energy Agency, all the people who do long-term planning for emissions reduction recognise the need for sequestration of some time because there are going to be emissions from hard-to-abate sectors. So we've got biosequestration, specifically in this case, soil carbon sequestration, and geosequestration through carbon capture and storage. So I want to take our focus back to hydrogen now, and I'm going to look from an Australian perspective about hydrogen in that Australian future. So let's go back and look at those portfolio of technologies from the low emissions technology statement. Where does hydrogen fit in? Well, clearly it fits into the first one, but it also fits into low emissions steel. Low emissions steel is steel that instead of using metallurgical coal for heating, uses renewable electricity for heating, and instead of using that metallurgical coal again as a chemical to strip the oxygen off the iron oxide, uses renewable hydrogen as the chemical to strip the oxygen off the iron oxide. And around Australia, you're seeing enormous levels of activity. I'm not going to read through these specific little boxes of investment activity, but the Commonwealth and every state and territory has funded activity supporting the private sector in developing either hydrogen production capabilities or the derivative ammonia production or utilisation opportunities. Most of it, in fact all of it at the moment, is renewable electricity produced hydrogen, where you take solar electricity or wind generated electricity and crack water through a process called electrolysis. And because the price and availability of wind and solar just keeps getting better and better and better, this becomes an economically more viable approach as we go forward. But the critical issue is the supply and demand equation. If I represent the supply side by the proverbial chicken and the demand side by the proverbial egg, what we've got at the moment, and it's a worry, is that the chicken is very big. Australian development companies and investment banks are poised to produce hydrogen. If the worldwide demand exploded in the next 3 years, the Australian developers would step up, I am sure, and meet that demand very quickly. So the challenge is to build up the demand. So let me go through 4 or 5 ways of building up demand. Well, one use of hydrogen is electricity generation. We wouldn't use it in Australia for mainstream electricity generation, but countries like Japan would, because they are dependent on imported energy for 94% or more of all of their energy needs. And Japan has led the world in declaring its strategic position on using clean hydrogen, clean ammonia for electricity generation. They've set some price targets for 2030. They will be more aggressive going forward to 2050, and some import volume targets. In Australia, we will use hydrogen for specialised electricity generation in microgrids. For example, in a mining site in the Pilbara, where there's tons of solar and wind, they can generate the electricity, use it to charge batteries for quick and short-term use, but also create lots and lots of hydrogen. They can store the hydrogen. The hydrogen can be used for directly powering the mine site vehicles and the drilling machines, the mine site, and ultimately the trains that take the iron ore or other mining products to the coast. Transport, huge opportunity in transport. That picture there is of a Hyundai full-size truck called the Exient. Just for Switzerland, Hyundai has a contract to deliver 1,600 trucks between now and 2025, all running on hydrogen, and they've delivered about 15 in the last few weeks to Switzerland, and they're already operating on the Swiss roads. Trains are a fabulous opportunity for hydrogen, where you've got trains that are running outside of the urban network with overhead electricity lines. Those trains today are diesel trains. Now, when somebody says a diesel train, what they really should say is they are diesel electric trains. The diesel is running a motor which drives a generator which powers electric motors to power the wheels. Hydrogen can just replace, hydrogen and fuel cells can replace that diesel engine very easily. The French company Alstom is leading the world in this, and they've got their trains running already in the Netherlands. These trains, by the way, have a 1,000-kilometre range, and they've got them already running in Germany, and they've just announced in the last few weeks that they've been authorised and the sales have been contracted for them to be running in Austria and Italy. So it's starting to happen. Shipping the actual fuel to power the merchant fleet of the future is an incredible opportunity for ammonia, which is derived from clean hydrogen. So the IMO, the International Maritime Organization, has declared its goal to cut emissions from international shipping by 50% of a 2008 baseline by 2050. Now that's hard. It's really hard because the number of ships ploughing the oceans by then will go up. So the emissions per ship on average across the fleet has to come down by considerably more than 50%. So in reality, they're going to have to start building and using zero emissions ships pretty soon. Now, there's two ways to do that. One is to directly use hydrogen to power fuel cells, to power electric motors. And there are a number of ships, ferry-sized ships that have been declared that are being constructed over the next year or two, but none on the waters at the moment. And the other way is, instead of using the hydrogen derivative of ammonia or hydrogen as a fuel cell component or drive, you can use ammonia derived from the hydrogen directly in a modified diesel engine. Now, there's a number of companies looking at this. This is an engine from a marine engine from a company called MAN. You can see it's huge. There's a little stick figure up the top there. These monstrous diesel engines can be modified to run directly on ammonia. The only real challenge is you get a lot of nitrogen oxides, and that's what the company is working on. That needs to be resolved, but they're very confident that they can do that. And that would enable the merchant fleet, which is responsible for 2 or 3% of all global emissions, to become ultimately zero emission. Industrial feedstock, hydrogen can be used to make ammonia, which can be used to make fertilizers. So we can have green fertilizers for food throughout the world, and as I've already indicated, green steel production. Gas blending to ultimately replace the gas that is distributed to our houses and factories. You'll see that throughout Australia there are already 4 small projects going on in suburban settings to start using 10% hydrogen by volume in the gas networks. And New South Wales and other states have indicated their goal, not necessarily a legislated requirement yet, but their goal for all of the hydrogen to become 10% hydrogen by the end of the decade. And then after a review, the intention would be to go towards 100% hydrogen. And that's what they're planning to do in the UK and Norway. HyDeploy is a project to connect more than 3 million dwellings and factories to pure hydrogen in the north of England. And that will be powered by hydrogen that is actually not made from renewable electricity, but will be made from natural gas imported from Norway, processed to produce hydrogen. The byproduct is carbon dioxide, and that carbon dioxide will be taken back to the depleted oil and gas fields in the North Sea by the Norwegian carriers and buried through CCS essentially forever. And finally, export potential. Last December, a year ago, I had the joy of being in Kobe, Japan, to go to the launch of a ship called the Suiso Frontier. It's a nearly full-size carrier ship. Suiso, by the way, is Japanese for hydrogen. And it was exciting. Just being on the ground and looking up a huge ship like that is a stunning feeling. It was exciting because this was the first ship of its kind ever built. But it was even more exciting when I realized it was the beginning of a new era for humankind, a new era where we can transport clean energy across the planet from one continent to another. Of course, for decades, for hundreds of years, we've been transporting fossil fuel energy across the planet, but now we will be able to transport renewable, clean energy between the continents. So let's go back to that demand-supply equation. We're looking at 5 different demand builds. The egg gets bigger each time. By the time we put the effort in and develop the demand, we get to the economic ideal, but I've got to say it might not be biologically ideal from the chicken's perspective, where the egg is as big as the chicken. Now, you might have noticed I didn't mention air transport because it's hard. We're just not there yet. We are, though, if you look at some of the absolute extremes of air travel or aviation travel. That picture there is of an extraordinary aeroplane called the X-15, which flew in the 1960s. And in 1967, flown by a pilot named Bill Knight, that plane achieved the world airspeed record for a piloted vehicle of roughly 7,300 kilometres per hour. And that is still today the speed record for a piloted vehicle in the air. Its engines were powered by liquid ammonia, pure ammonia and liquid oxygen. Now, the most extreme, of course, is the Space Shuttle. The Space Shuttle had 2 types of engines, the big booming bright flames coming out the bottom there. They're from the solid fuel booster rockets, which were effectively just sticks of dynamite that were composed to burn slowly. But the 3 bright dots above, which are part of the main spacecraft, are from the main engines, which run on liquid hydrogen and liquid oxygen. And the nozzles are bright white because of the heat of the gas coming out of it, but you can't see any gas whatsoever because pure hydrogen burns with a clear flame. So just to finish, to summarise, what we've seen on our journey into the clean energy future is that solar, wind and large-scale hydroelectricity can provide enormous primary energy for our planet. We've tried to capture the opportunities in the low emissions technology statement. Hydrogen coming in from the left is assisting because whilst electrons from solar, wind and hydro will supply 85% of our end user needs, there will be occasions where we need a high density transportable fuel and chemical to meet our energy needs into the future, and that's where hydrogen comes into it. Now, everything I've talked about so far is a strategy that's in place and being developed. The third roadside marker I've got there, the Glasgow statement, is a statement that the government has declared that it is producing for announcement at the COP26 meeting next year in Glasgow. So that should be significant. That will pick up policy issues and other issues that are not picked up in the low emissions technology statement. And all up, these are a significant part of our journey into the future. I'm often asked what short messages I would leave people. I've got two. First, be ambitious. But second, this is the long haul, so you have to be patient. Thank you.
Well, thank you, Alan, for a really interesting talk today, and great to see you again. We've received some questions from our attendees today, and I'd like to go through some of those now before we wrap up and proceed to the rest of the event.
Terrific.
So, some questions. So, a number of recent reports suggest that limiting warming to 1.5 degrees may now be beyond reach, and we are rapidly exhausting the carbon budget to keep below 2 degrees. Now, since climate policy isn't fixed and needs to respond to the latest climate science, how in a technology-driven approach do we maintain that flexibility and the ability to modify our responses as the science advises?
A couple of things there, Michael. Basically, maintaining or restricting the temperature rise to 1.5 degrees in Australia, it's effectively almost beyond hope, because we're about 1.4 degrees above the early 1900 levels. It's a little bit uneven across the planet. I think planet-wise, the rise is slightly over 1 degree, so it's a almost impossible to achieve challenge. We have to do the best we can possibly do. I do question the axiom behind the second part of your question, that the response has to adapt to the latest science. To me, the science is clear and conclusive that atmospheric emissions of greenhouse gases, anthropogenic emissions of greenhouse gases, cause global warming. It's basic physics, and you see it through the actual emissions, the rise in the atmospheric concentrations, and the temperature increase. New science is not going to, I don't think, change that. We have to respond, and the appropriate response is to focus on atmospheric emissions, not technology per se. I'm often in a situation where I'm responding to people either promoting their favourite technology or denigrating their most despised technology, and I try to encourage them, focus on the outcome. And the only outcome is atmospheric emissions. The outcome isn't the percentage of renewable electricity in the system. Renewable electricity in the electricity system is a way of reducing atmospheric emissions. But we need to be focused on reducing atmospheric emissions. So to sort of recapitulate on the answer, it's going to be very, very difficult to restrict global warming to 1.5 degrees. In Australia, we're almost at that point, but we have to keep up the effort and work as hard as we can to limit emissions of carbon dioxide, methane, those two gases in particular, as hard and as fast as we can. Recognise that it's inconceivable that all emissions, especially when you include agriculture and other industrial processes like cement manufacturing, it's inconceivable that all emissions can actually be eliminated. So there has to be a mechanism to draw carbon dioxide out of the atmosphere in order to achieve net zero. So geosequestration through carbon capture and storage will be important in the future. Biosequestration through forests, through soil organic carbon will be important in the future. Geosequestration by drawing carbon dioxide out of the atmosphere using electricity to pump the atmosphere across absorbing membrane is technically conceivable, but at this stage looks like it will be permanently too expensive. But you never know, technology can deliver beyond expectations. We have to look at everything, reducing emissions hard and fast, and taking atmospheric carbon dioxide, or taking carbon dioxide out of the atmosphere and basically burying it essentially forever.
Yes. And so with respect to, you mentioned net zero a few times there, A supplementary question we've received is, so how important would a net zero target by 2050, or maybe even an earlier date, be as part of planning for these kinds of futures?
You know, obviously a lot of people hold that to be dear, but to me the most important thing is that we're doing the best we can at any given moment to drive emissions down and hard and fast, to do that hard and fast. If the government had a date for achieving net zero today, we would be doing the kinds of things I was talking about in my talk today. We would be looking at technologies, because let me cast it a little bit differently. The problem we face today are the problems of civilization using technology to give us the energy and industrial processes that we need. So it's a problem that's been wrought by technology, and realistically, the solution is going to be delivered by technologies. And the idea is to develop new technologies that are low or zero emissions technologies, get them to the point where they're large scale, they're cost competitive with the incumbent high emissions technologies, and effectively make those incumbent technologies obsolete. So it can be done. We would start with the kinds of things that are in the low emissions technology statement, the national hydrogen strategy, a stable electricity system. We would add on to that the kinds of things that ideally will come out of the Glasgow statement. I called the title of my talk Pivoting to the Future, or something like that, because we are pivoting. We're in a place today that it would have been hard to conceive of just a few years ago, and I'm encouraged. Can we or should we go harder and faster? That's a decision that our politicians have to make. What I can do and what others can do is advise our political leaders on what we could do that can get us to the end point as fast as possible, but consistent with having a prosperous Australia.
Yes. And if you think about the science, keeping up a theme at the moment on the science informing policy, we're still in a remarkable period, a 1 in 100 year period of the global pandemic on COVID-19, the Chief Medical Officer and others have been tremendously effective in informing government, state and Commonwealth on what shouldn't be done, and we've achieved a great deal where the evidence base, the scientific evidence base, has informed remarkable measures by governments. So what does that say to us in the abatement challenge and this climate change challenge, where this rapid learning and translation of science into policy and action has occurred in the last 6 to 12 months, and hopefully will continue to occur? What does that mean for our ability to meet climate change objectives, and maybe a change of appetite in governments in responding in such a way?
Well, first let me say I agree with your observation. The way that Australian governments, and I pluralise that, it's the Commonwealth Government and the state and territory governments, have listened to and based decisions on the experts in the public health system this year has been quite remarkable, and has been part of the reason why Australia has done so well in the face of the COVID-19 pandemic compared to comparable countries internationally. So that's very encouraging. But I'd also put it to you that in the last few years, the governments, and I'm pluralising it again, have been listening to the climate scientists and the technologists. And that's why you're seeing that virtually every state and territory government has active plans in place to achieve targets such as 50% renewable electricity by 2030 and other targets. They're investing in clean hydrogen, they're investing in solar, they're investing in wind, or supporting it, they're investing in batteries. They're doing the things that will be necessary in order to reduce atmospheric emissions. They've accepted that atmospheric emissions are what causes global warming, and global warming is what causes climate change. The Commonwealth Government has accepted it. At the beginning of this year, in a speech to the National Press Club, the Prime Minister was unequivocal about climate change being responsible for the Black Summer bushfires, and will continue to cause havoc of that kind, and that's why he asked the CSIRO to do a report on climate and disaster resilience and asked for there to be an expert advisory panel that I chaired advising the CSIRO. So the science has been accepted, and what to do about it, I've already referred to the state and territory governments and the Commonwealth governments in terms of renewable electricity and storage. We've got the national hydrogen strategy. Clean hydrogen is not going to transform the situation in the next few years, but in coming decades, it will be a very significant contributor to the reduction of emissions. And now we've got the low emissions technology statement, which was informed significantly by the ministerial reference panel that I chaired, and the consultants who we tapped into, including the CSIRO and university academic experts. So I actually think that there's a robust process in place already. During the course of the year, I had the opportunity to convene a new forum called the Rapid Research Information Forum, the RIF. And the Rapid Research Information Forum has been very successful at doing exactly that. What the RIF does is it takes a single question from a minister about something so far related to COVID-19, but not necessarily the public health aspects of it, and provides a clear answer from the best academic experts in Australia based on the up-to-date published and preprint results that are out there, but filtered through the lens of those experts. And they're public reports, they've been well received. They're not just about the public health aspects, they could be on workforce impacts, they could be on learning impacts for kids who are doing distance learning. So that's a new mechanism that the government is accepting and actively taking advice from. So I think that the situation is probably better than many people think, and particularly in the last few years.
Yes, yes. Now, a slight change of tack. Academics and postdocs and students, we think about research an awful lot and teaching and other things, but research is not the be-all and end-all of this grand journey towards a low emissions future. It's innovation and doing new things that get us to these low emissions futures. I want to talk a bit about the balance between research and innovation, and also the balance between what government sees its role in driving innovation rather than, putting it bluntly, doling out more research funding to universities and other organisations. So what role does government see itself relative to the private sector in particular in exciting and encouraging innovation that can really unleash this productive power that the private sector has?
So I agree with your opening comment there that delivering benefit for our broader community is much more than just research outcomes. Innovation is taking those fabulous research outcomes and other bright ideas that aren't necessarily based on research and turning them into some sort of utility, some sort of goods or services that increase the economic or social or environmental value for our society. Government really does want to do something about encouraging that. It's not that easy. It's in a sense easier to see the results of a direct investment in research. You put enough billions into it, you get enough people working on it, you get more papers, you measure the metrics as papers and other research results. First of all, innovation is harder to measure. It's much more than just patents, it's much more than just papers. It's what you've seen during the pandemic, where restaurants have come up with whole new ways of putting sophisticated meals together and charging people and delivering those meals in ways that were inconceivable, where you get instructions on how to cook them. You get the sort of pleasure of cooking your own meal, but all the thinking has been done and the preparation and purchasing has been done by the restaurants. So innovation can appear in all sorts of places. I think one of the strongest areas of innovation in Australia is our mining companies. The fact is that Australia has more than half the world's exports of iron ore. Export market of iron ore, that's a massive percentage. There are a lot of competitors. And it's not because we've got the cheapest wages. It's because we've been the most innovative in modernising our mining systems through automation and artificial intelligence, fly in, fly out, all sorts of things, control centres that are remote. And we've been able, through that innovation, to lower the costs and improve safety at the same time and lower the environmental impact at the mining sites. So what can the government do about it? Well, you've got to go beyond the research into translation and demonstration. And I think we do that very well in the energy sector and less well in probably all other sectors, with the possible exception of biomedical. In the energy sector, we've got a clear pipeline where you've got, not enough, but funded research for investigator-driven discovery research, the kind of stuff that academics love doing. There are translational research capabilities, particularly in the CSIRO and some of the other publicly funded research agencies. There's funding for demonstration of what comes out of the translational stage through ARENA. I'm just talking about the energy sector now.
Yep.
Through ARENA, the Australian Renewable Energy Agency. And then the projects that have survived till then have the opportunity to go out to the private sector, but also to the government green bank, the Clean Energy Finance Corporation. If we could have that kind of multi-stage pipeline in other sectors, that would help both the research and the innovation, and make sure that we tap into and capitalise on both.
So we've talked a lot about energy today, but you've done some important work on the R&D tax incentive and other things, which made recommendations, I think 2 or 3 years ago now, related to some of those changes. So perhaps that's a work in progress for everybody, to really get those structures in place across the whole economy, not just in the clean energy sector.
Well, we do have to be investing across the whole economy. The R&D tax incentive is one way. It's actually not the way that is used by many other countries. In the strategic document called Prosperity 2030 put out by Innovation and Science Australia, it did note that Australian government funding of industry-based research is predominantly at the 90% level through the Research and Development Tax Incentive, which is an indirect mechanism, whereas in most other countries, that's a small percentage of government funding for research in industry, and the rest of it goes out through challenge-based innovations and other programs. And there is a pilot program called the BRII, the Business Research Innovation Initiative, being run by the federal government at the moment, to look at ways of boosting the more direct funding in innovation through industrial research. Getting the balance right is important.
Yes, it's very difficult. It's a complex task. Well, one final question, it's a more general question, and it's about yourself personally and your journey on the clean energy transformation. I know myself, my views on these things are changing all the time, and sometimes quite significantly. We've worked together a couple of years ago on the Finkel review, but many of our attendees today wouldn't know we actually did a little bit of work earlier than that on electric cars.
We did.
I think would be interested to know how your own views on energy broadly have changed, particularly positions on nuclear, carbon capture and storage, and renewables, and what do you think that means? What, as our collective views may evolve over the next 5 to 10 years?
Well, one thing, to go to your last part of the question first, it's an argument, what I'm about to say is an argument of having an open mind and being ready to embrace the opportunities that changing circumstances bring. So for me personally, if you went back to 7 or 8 years ago when I was working in an electric car charging infrastructure company, I was one of the strongest critics of hydrogen as a fuel for electric vehicles. Batteries have a clear advantage for small cars, particularly in terms of the kilometres that you can drive per original kilowatt hour of electricity that was used to either charge the battery or produce the hydrogen. But since then, I've seen the utility of hydrogen for big long-haul vehicles such as trucks and trains, and clean hydrogen to make ammonia for ships, and the opportunity to export energy to countries that need it. So for me personally, the realisation of the important role of hydrogen is a clear change. The incredible rate at which lithium-ion batteries have improved in every single respect their lifetime in terms of charging cycles, their price coming down very rapidly, and their actual energy density. Look, there's just innovation everywhere that has to be adopted. I think that the worst thing that we can ever do is become entrenched and say there's only one way to achieve the goal. The goal, as I said before, is lowering emissions of carbon dioxide and methane into the atmosphere as the two primary gases. There are others, as quickly as possible.
Well, thank you, Alan. That was a really good answer and a good wrap up for the Q&A. We're going to move on to the rest of today's session, but thank you, Alan, for everything today.
My pleasure,
thank
Mike.
you.
You keep up your good work too.
For your generosity throughout your term as Chief Scientist and to the community, of course, but to the research community, I guess, more specifically. We also welcome the next Chief Scientist, Dr. Kathy Foley, in a few weeks, in January 2021, and we wish her all the best in what will be, I'm sure, a substantial and challenging period. It's a tough job and a very, very important job. Now, we know that you've made several important contributions to the energy sector. I mentioned also on innovation more broadly as well over your time. We provide a little bit of help for you on the Finkel review, the power system security assessment work led by my colleague, Professor Pierluigi Mancarella. But we hope today's symposium is demonstration of our ongoing commitment to our shared and the community's shared objective of getting to these clean energy futures. So today's talks include some of the topics that you talked about today. We have plenaries, important plenaries on clean energy investment, on hydrogen and clean energy export, on zero emission aviation.
There you go.
from a colleague of ours at Cambridge University. And of course, an MEI Symposium wouldn't be complete without some work on energy system planning, of course. So we now thank our virtual attendees. Thank you, Alan. Thank you to Professor O'Brien, our incoming Dean of Science, and wish everybody all the best for today's symposium. Thank you.
And my thanks to you and your colleagues. Good luck.
Our pleasure.